Now, let us first understand that what is the concept of earthing. Earthing is concept of connecting a thing to the earth or the ground. So earthing means anything which carries the current, we have to connect it to the earth. In power systems, engineering, earthing is the one concept that cannot be dispensed with. So in power system, earthing is very important and we cannot ignore it. The generators, the reactors and transformer have to be earth at their star or neutral point for proper operation and application of the earth fault relays. Now the generators, reactors and transformer, they have got the star connected winding. The neutral point of the star connected winding has to be connected to the ground so that in the event any earth fault takes place, the current should flow through the neutral, and there are a current transformer and the protection relay which will scan this current and disconnect the equipment. Normal course of operation, the current flow through the neutral in a balanced power system will be zero. So this neutral current will flow only in the event of the electrical fault is there. For the realization of the single phase voltage supply, suppose in the distribution system, we give the single phase supply in the form of the phase at the neutral, and neutral is grounded. And drainage of harmonic voltage. So there are certain non-linear loads like the computers, the laptop, and the conversion units which convert AC into DC. These type of power system, they generate the harmonics into the system. So these harmonics has to be dissipated to the ground. Furthermore, the metallic enclosure and the non-conduction part of every apparatus require earthing for the protection of the personal and users from the electrical hazards. What happens? All type of electrical equipment, whether it is a generator, whether it is a electric motor or transformer, or in the industrial setup, the welding machine, or in your household, the refrigerator, the mixer grinder, the vacuum cleaner, all these current carrying equipment or the geyser, they have the metallic covers. The current carrying equipment is embedded into that, and these metallic covers of these electrical equipment, they may have the charge accumulated over them, because the current carrying equipment in these electrical equipment, they have got the insulation. As we know, there is no perfect insulation discovered till today. So all the time some electrons will leak through the current carrying metallic parts and come over the surface. Now these electrons which are deposited over the surface of these current carrying equipment, metallic covers, if somebody touches it, then these electrons will pass through his body, because we know our human body is also acting as a conductor. The body is not a insulator. So the electrons will pass through the body and they will create the problem into the various organs of our human body. So in order to avoid the migration of these electrons from the metallic covers through human body and causing the electric shock or hazard to the human person who are responsible for operation and maintenance of these equipment, we have to connect all these metallic covers of these electrical equipments with the ground, so that whatever electrons leak penetrate through the insulation, they will safely discharge to the ground, and the person who may come into contact with these electrical equipment will not get electrocuted. So in all electrical equipment, there are two purposes of the grounding. One is for human safety, so that somebody should not get electrocuted, and another is for the protection of the equipment. It is inestimable the quantity and values of the lives and property that would have been lost to the electrical faults. Now, electrical fault, every power system comprises of three basic elements. One is the current carrying conductor, either copper or aluminum, through which the electrons flow. And another is these current carrying conductors are covered by the insulation. Okay, the role of the insulation is to arrest the migration of electrons from current carrying conductor into the ground. And the third element of all type of power equipment is the silicon steel core. The core in the transformer, generator and motor, it is used to transfer the magnetic field from primary circuit to secondary circuit. So out of these three, that is the steel, copper and the insulation. Insulation is the most delicate material, because the insulation, if it is designed for F-class insulation, will lose its property to retain the electrons at a temperature beyond 155 degrees centigrade. The copper can sustain a temperature of 550 degrees centigrade, and the steel can sustain a temperature of 1050. So out of these three materials in all type of electrical equipment, insulation is the weakest link. Now this insulation, if subjected to high voltage and temperature, may lose its property, can be damaged, and the electrons, instead of flowing into the copper, they will penetrate the insulation and go into the ground. The moment this occurs, the migration of electrons from current carrying conductor to the surface penetrating the insulation is called the electrical fault. Now, whenever electrical fault occurs, these metallic covers of these electrical equipment, a transformer, generator, motor, they will have sufficient charge on the surface, and if somebody touches these equipment during the fault, they will definitely get electrocuted, and the many lives of the animals and the human being will be lost. Power system engineering is that field of conscious human endeavor in which energy is generated, converted and transmitted for the purpose of the distribution and eventual utilization for the benefit of the man and the beast. So the power system is one field where the power is generated, power is transmitted, power is stepped down in the distribution transformer, and ultimately it is sent to the various category of the consumers, that is the commercial consumers, the domestic consumers, the agricultural consumers, and the industrial consumers, and they use this electricity. In this connection, however, it is mechanical energy that is generated in most of the cases. The mechanical energy in the steam turbine, in the gas turbine, in the hydro turbine, this mechanical energy is converted into electricity. The concept of earthing in power system engineering is as old as this field of endeavor itself. So it is a very old concept of earthing the current carrying equipment. It came into play from the age-long fact that the earth is a universal sink. Universal sink means whatever charge you inject into the earth, it will be dissipated, and it is assumed that the potential or voltage of the earth is zero, in spite of so many charges in the form of lightning charges or in the form of the electrical fault is pumped into the earth. The voltage of the earth or the potential of the earth will always remain zero. Thus, this concept has to do with the connection to the general mass of the earth in such a manner so as to ensure immediate drainage of the energy into the same without danger. So that's why all the electrical equipment has to be connected with the ground so that the leaking electrons through the insulation can be diverted to the ground and the human safety is ensured. Therefore, earthing features prominently in the power system protection schemes. So that's why this earthing is prominently playing a big role in the protection system. Now, the protection system is a system which will scan the voltage and the current flowing through the power system. As long as the insulation is good, the voltage and the current of the power system will be as per specification or the normal voltage and normal current. Whenever the fault occurs, the electrons will penetrate the insulation going to the ground, and then when it returns from the neutral, there are current transformers which will scan this current and disconnect the faulty equipment from the power system. Indeed, the application of the thing is so widespread in the electrical power system that at practically every point, there from generating station to the transmission line, to the substation, to the very point of utilization in your home, into the commercial center, into the industrial utilization of the agricultural system, everywhere the system has to be grounded. Two major categories of earthing are employed in practice, namely neutral or the mains earthing. First is the neutral of the power equipment is grounded, that is the copper, and the body of the electrical equipment is grounded. So there are two type of grounding system. One is the body earthing and another is the neutral of the generator, of the transformer, or the star connected motor has to be connected to the ground. Now the system is like this. There is a copper in the all type of power system which carries the electrons, and this current carrying conductor is covered by the insulation. The role of the insulation is to confine the electrons flowing into the copper itself, and then this insulation, like in the motor, generator, transformer, is covered by the silicone steel. So there are slots or the windings are in the silicone steel, and as I told you, the insulation is not a perfect insulator. Some electrons will always leak, penetrate the insulation and coming to the core, which is grounded. This core of all the transformer, generator, motor, this is connected to the ground. So these leaking electrons will migrate to the ground. Now, in order to assess the condition of the insulation, what we do, we apply a DC voltage through the insulation tester or megger, and we measure the leakage current. So the voltage applied by the megger and the leakage current which flows from current carrying conductor penetrating the insulation is measured, and this is called the megger value. Now, when the insulation is perfectly good, then the leakage current is flowing through the nanoampere, and we say the IR value of the insulation is in gigaohms. If the leakage current increased from nanoampere to microampere, we say the IR value is megaohms. If the leakage current increased to ampere, we can say the IR value of the insulation is kiloohms. And if the leaking current is in the amperes, the IR value is in the ohms. And if the insulation value decreased to milliohms, we say the leakage current goes to kiloampere. So this is what happens when the insulation deteriorates from a very good insulating quality to poor insulating quality. And whenever this current, leakage current through the insulation increases amperes or kiloampere, we say that the electrical fault has occurred. Now, this silicon steel, if it is not grounded, these leaking electrons, because the silicon steel is mounted into the steel frame in the case of transformer or in the case of motor or the generator. So this will go to the human body and the electrical shock will be observed. Now, what is the difference between a conductor and the insulation? Now you see, under the influence of the potential difference, the flow of electrons through the copper takes place only through the conduction band. So there is a valency band that is the last orbit of the electrons, and under the influence of the potential difference, the electrons cannot flow from the valency band. So for the electrons to flow through the copper, these electrons in the valency band has to migrate to the conduction band, and then the flow of electrons from one atom to another atom or to the potential difference or the positive terminal of the voltage is taking place in the conduction band. Now in the case of conductors or the metal, the gap between the valency band and conduction band is very narrow. So under the application of say a few millivolt or microvolt, these electrons will be able to migrate from valency band to conduction band, and from this conduction band they will flow to the positive terminal of the source. Okay, so the energy required from migration of electrons from valency band to conduction band is very low in the case of conductor. Now, in the case of insulator, this gap between the valency band and conduction band is very large. So, even if the voltage is applied or the potential is applied across the insulator, these electrons will remain in the valency band. They cannot go to the conduction band. That's why if you apply a voltage or potential difference across the insulator, no electrons will flow because the availability of the electrons in the conduction band is zero. But if the insulator is subjected to high voltage or high temperature, under the influence of high voltage and high temperature, these electrons can migrate from valency band to conduction band, and then they will flow to the silicon steel or the ground. Now, whenever this happens, that these electrons in the insulator can migrate from valency band to conduction band. This is called the electrical fault.